A post-production supervisor gets a call at 11 p.m. the night before an editorial deadline. A 3-minute scene from a 2019 production cannot be located. The metadata was never updated from the shoot. The script supervisor notes were never digitized. The only person who knew where the original camera cards were stored left the company in 2021. The scene exists somewhere. Nobody can prove it. Nobody can find it. The budget and production plans call for the 2019 asset, and the editor and their team are waiting for the shots. A reshoot is not possible because the lead actor has aged visibly in 5 years and the character has not. In a franchise where continuity is contractual, this is not a post-production problem. It's a revenue problem with a deadline attached. Intelligent document processing does not prevent actors from aging. It prevents the metadata from disappearing. This is uncatalogued production assets are not an archive problem, they're a revenue problem. ML Part 25. Why intelligent document processing is the pipeline between a film shoot and a searchable, licensable, monetizable asset library. Section 1. What IDP actually solves. Every film and television production generates documents that describe what was captured, where, by whom, under what conditions, and for what purpose. Script supervisor notes track continuity between takes. Slates record scene, shot, and take identifiers for every camera roll. Call sheets document which cast, crew, locations, and assets were present on which day. Camera metadata captures technical parameters for every recorded frame. Production design documents catalog props, set designs, and practical effects. Visual effects breakdowns identify which shots require digital work and which elements need to be tracked. In a major production, these documents number in the thousands. They arrive in formats that no single system natively understands. Handwritten continuity notes, PDF call sheets, XML camera metadata reports, Excel-based VFX breakdowns. The production wrapped, the documents exist. The information inside them is effectively inaccessible to any downstream system until someone reads them, understands them, and writes their contents into a form that media asset management systems can query, license desks can search, and post-production workflows can consume. This is what intelligent document processing does. It's not a single model. It's a pipeline of machine learning components that each address one stage of the transformation from unstructured production document to structured, validated, searchable asset record. Section 2. The 8-stage pipeline. Every serious IDP implementation in media and entertainment runs through the same stages, regardless of which vendor built it, which cloud runs it, or which studio commissioned it. The stages do not change because the problem does not change. Ingest is where raw materials enter the pipeline. Camera cards from set, editorial exports from Avid or Premiere, scanned paper documents from production offices, PDF deliverables from vendors. The ingest layer normalizes formats, validates completeness, and routes each document type to the appropriate downstream processing chain. A handwritten continuity note and a structured XML camera report require different processing paths, but both enter through the same ingest layer. Recognition is the stage most people associate with IDP because it is most visibly technical. Optical character recognition converts printed and handwritten text to machine-readable form. Handwritten recognition handles script supervisor notes, director's annotations, and production office paperwork that was never designed to be digitized. Natural language processing extracts structural information from recognized texts, scene numbers, character names, location identifiers, take counts, continuity flags. Computer vision separately analyzes visual content to identify on-screen text, billboards, brand placements, signage, and incidental text that appears in frame and carries rights and clearance implications. Entity and object detection goes deeper into the visual content. Character recognition matches faces to cast records. Location identification tags physical environments against production location databases. Prop and set dressing classifications catalog physical assets that appear in the shot. Visual effects element detection identifies shots containing practical and digital effects work that require downstream VFX pipeline tracking. These detections are not just metadata enrichment. They are a foundation for rights clearance, residual calculation, and franchise continuity management. Structured abstraction pulls recognized and detected information into the formal vocabulary that downstream systems expect. Scene, slate, shot, sequence, participant, and asset are not informal labels applied to individual productions. They are formally defined concepts in the Movie Labs ontology for media creation, the OMC, which was co-developed by DreamWorks Animation, Marvel Studios, Paramount Pictures, Sony Pictures Entertainment, Universal Pictures, Walt Disney Studios, and Warner Brothers, precisely because every major studio had the same problem and none of their bespoke systems could talk to each other. The OMC is now at version 2.8 and covers production workflows from pre-production through post and into distribution. Structured extraction maps IDP outputs to OMC concepts rather than to any single studio's proprietary schema. Disambiguation and ambiguity resolution handles the terminology conflicts that production environments generate constantly. A script supervisor writes INT for interior, a different supervisor writes interior on the same production. A third writes I/E for a scene that transitions between interior and exterior. The resolution layer maps all three to the same formal OMC concept using the controlled vocabulary and disambiguation rules we covered in Part 17. This step is where production vernacular, which varies by crew, by country, and by decade, gets reconciled against the formal definitions that downstream systems can act on consistently. Identity resolution and IDR, or EIDR registration, addresses the content identification problem that the Entertainment ID Registry was built to solve. IDR functions as a universal, unique identifier for film and television content, doing for content what UPC codes did for retail. It won a technical Emmy for automating digital distribution in an industry where the same work had different identifiers in every system it touched. The IDP pipeline matches extracted content identities to existing IDR records where they exist and mints new identifiers for unregistered works, clips, derivative edits, and localized versions. Without this step, the same physical scene can exist as an unconnected record in the production system, the editorial system, the distribution system, and the archive, with no mechanism to recognize as they describe the same content. Metadata validation enforces schema constraints before the record touches any production asset management system. This is the shackle equivalent for media pipelines. A scene record without a valid slate identifier fails validation. A participant record referencing a cast member not in the production SAG-AFTRA contract fails validation. A shot record claiming a location identifier that does not exist in the approved location database fails validation. These constraints exist because bad metadata that enters a MAM, PAM, or DAM system does not stay contained. It propagates into distribution packages, licensing databases, and archive systems where it costs orders of magnitude more to correct it than would have cost to catch it at ingest. Registration and indexing is the final stage where validated, identified, and ontologically grounded asset records are written in the appropriate asset management system as searchable, licensable, rights-cleared entities. A properly registered asset is findable by scene, by character, by location, by date, by right status, by technical specifications, and by any combination of those dimensions simultaneously. A scene from a 2019 production is findable at 11 p.m. the night before a delivery deadline. A music cue is clearable before the edit locks. An Iron Man suit from Phase 2 is locatable before a visual effects team spends 6 months rebuilding it from scratch. Section 3. Why the metadata is the asset. The media entertainment industry learned a lesson that every other content-intensive industry is still learning. The value of a production asset is not determined by the quality of the content. It is determined by the accessibility of the content. A perfectly shot scene that cannot be located, cleared, or licensed is worth nothing. A mediocre take with complete, accurate, rights-clear metadata is licensable, searchable, and monetizable across every downstream window the content will ever touch. Most production organizations are not missing content. They're missing the pipeline that makes content accessible. The difference between a content library that generates revenue and one that generates storage bills is not the quality of that shot. It's the completeness of what was cataloged. The Movie Labs OMC and IDR provide the industry-wide semantic foundation that makes IDP outputs interoperable across organizational boundaries. A studio that catalogs its assets against OMC concepts can exchange production data with a co-producer, a distributor, or a post-distribution vendor without custom data mapping between bespoke schemas. The same interoperability logic we examined in the federated knowledge discussion in Part 20 applies here. The standard is the same semantic layer that makes the exchange possible. Section 4, where IDP breaks down in production. Recognition quality degrades on poor source material, handwritten notes from a script supervisor working in difficult conditions, coffee-stained, written quickly in low light, with idiosyncratic abbreviations, challenge even the best handwriting recognition models. The pipeline needs confidence scoring in the recognition stage and human review cues for low confidence outputs, rather than forcing every recognition result into a structured record regardless of quality. Domain vocabulary drift is the concept drift problem from Part 12, applied to production terminology. Slang evolves. The new production technologies introduce new terminology. International co-productions mix vocabulary across languages and production traditions. Recognition and extraction models trained on historical production documents degrade as production vocabulary evolves. Retraining schedules tied into production calendar cycles rather than fixed intervals keep models current without requiring continuous monitoring overhead. Provenance gaps in the catalog create the exact failure mode the opening scenario described. A scene that was ingested, recognized, and registered without complete provenance tracking cannot be restructured from its metadata record alone. Where did this take originate? Which camera card? Which editorial version? When was the metadata written and by whom? Provenance at the asset level is not documentation overhead. It is the chain of custody that makes the catalog defensible when residuals audits or delivery requirements demand it. Section 5. Why this matters beyond entertainment. The 8-stage IDP pipeline that catalogs a film production is architecturally identical to the pipeline that produces defense logistics documentation, legal contract repositories, regulatory compliance filings, and government records management systems. The recognition models differ. The ontologies differ. The validation constraints differ. The pipeline does not. Every domain that generates documents faster than humans can read them, which is every domain, faces the same fundamental problem. Unstructured information that cannot be extracted, grounded, validated, or registered into a queryable system is not an information asset. It is an information liability. Intelligent document processing is the machine learning infrastructure that converts one into the other. Next, we examine how machine learning pipelines connect to language models and why the semantic grounding that IDP establishes is exactly what prevents language models from hallucinating explanations that contradict what the underlying machine learning system actually knows.